Welcome to Hobby Electronics. This is the 194th episode in this learning process. This particular episode is 65th part of microcontroller. Reading lookup table in 24C02 EEPROM using Arduino Uno and displaying 4-digit number. The objective of the present work: to use lookup table LUT stored 24C02 EEPROM and to display 4-digit number using 4-digit 7-segment combo module. Libraries needed for 24C02 EEPROM. The Arduino Uno has internal EEPROM. The EEPROM.h library is specifically designed for the internal EEPROM of the Arduino microcontroller. This can be more or less used for 100 times. Beyond that, 100 times writing and erasing, it becomes redundant. This library cannot be directly used with external I2C EEPROM like 24C02. 24C02 EEPROM is an I2C device. The wire.h library needed to write to an external EEPROM using I2C communication. After wiring the 24C02 EEPROM with Uno, use the scan code given in the previous episode and scan for the I2C devices. This will verify and validate the wiring and functioning of the IC2 EEPROM. The address of the EEPROM also can be identified using this code. Please refer to the previous episode. Steps for identification of the fault in case the address is not displayed or an error device not found message is flashed in the serial monitor. Incorrect I2C communication. Start/stop conditions. Ensure correct I2C start and stop condition are generated. 2. Slave address. Verify the correct 7-bit slave address for 24C02 EEPROM, including the read-write bit. 3. Acknowledge. If the EEPROM acknowledges the slave address and the data byte, a NAC indicate a communication issue. 4. Data format. Ensure data is transmitted and received in the correct byte order and format. Hardware connection. Pull-up resistors. Ensure appropriate pull-up resistors are connected to the SDA-SCL line. A typical value of 4.7K for 5-volt system is used. One can work around with 10K resistors also. Wiring errors. Double check all the connection between the microcontroller and the 24C02 for loose connection, short circuit or incorrect pin assignment. Solution. Visually inspect all the connection and use multimeter to check the continuity and for shorts. Check for specific chip version. Variation in chip exists. Always confirm the voltage for a chip you have by following these steps. Identify the manufacturer and the specific part number. Full part number may include suffix like -C or -R or other letters that indicate the voltage range. The manufacturer logo or name is often printed on the top of the chip. Look up the official data sheet. Use the full part number and find the manufacturer data sheet online. Websites like Octopart or All Data Sheet aggregate this information. Read the absolute maximum rating or DC electrical characteristic. This section of the data sheet will list the minimum and the maximum recommended supply voltage VCC for the safe, reliable operation. Solution for troubleshooting. Review your I2C communication code or library function carefully. Compare them against 24C02 datasheet I2C protocol and specification. Use oscilloscope or logic analyzer to monitor the I2C line, SDA and SCL to observe the actual signal. Identify any discrepancies in wiring. We have set an objective of creating lookup table for 7-segment display. This display can display letters from 0 to 9 and A to F. This display has two types, common anode and common cathode. And there are two more options, that displaying with dot and without decimal point. So 4 lookup tables are created and organized in the memory of EEPROM. The mathematics and the memory map. Each character 0 to 9, A to F requires 16 bytes per set. Since you have 4 distinct sets, your total layout will look like as given below. Set 0, common cathode without decimal point, address from 00 to 0F. Set 1, common cathode with data point, address from hex 10 to 1F. Set 2, common anode, no data point, address from hex 20 to hex 2F. Set 3, common anode with dot point, address from 30 hex to 3F. The total byte space used is 64 bytes out of 256 bytes available. The purpose of creating a lookup table. The purpose of lookup table in this setup is to translate the raw binary BCD input into exact segment pattern needed to drive the 7-segment display. It replaces dedicated decoder chip by instantly mapping an input value to the correct LEDs. In this page, the example of bitmap saved in EEPROM for one unit, one set is given. The A is the least significant bit and dot point is the most significant bit, and the bits are arranged in such a way so that it will display numbers from 0 to F. See the table marked with the square. The LUT loaded 24C02 EEPROM needed to proceed further. Please use the LUT writer C++ code given in the previous episode. The ITC EEPROM with LUT table in it needed for testing the display. This section pertains to 4-digit display testing without driver transistor. Warning: dim display. A 390 ohm resistor limits the total current to the entire digit to roughly 8 to 10 milliampere. When multiple segments are lit, like number 8, the current is split between them. The display will be noticeably dim, but it is preferably safe for the quick bench test. And the display brightness will fluctuate depending upon the number of segments lit. Note: writing LUT into EEPROM. The previous episode lists the detailed step for writing LUT in the EEPROM. The EEPROM 24C02 is an I2C bus based device. Circuit diagram of wiring of 24C02 EEPROM with Uno is given to recollect. The detailed C++ code given in the previous episode. Please follow the steps carefully to create a LUT table in EEPROM. Without LUT written data, in this episode of multi-digit display code will fail. Components needed to write data: Arduino Uno 1, EEPROM 24C02, 1 number, jumper wires, 47 kilo ohms, quarter watt, 2 numbers, breadboard small, 2 numbers. Pin diagram of DIP package of 24C02 EEPROM. Pin number 1, AD0. Pin number 2, AD1. Pin number 3, AD2. These 3 pins together decides the address of the I2C bus of the EEPROM in the circuit. Pin number 4 is the ground. Pin number 5 is the serial data. Pin number 6 is the serial clock. Pin number 7 is the write protect. Pin number 8 is the VCC, or power supply to the EEPROM. The circuit diagram of EEPROM configuration configured to address 50H is given here. The Uno connection is given in subsequent slides. Why the pull-up resistor is needed? The I2C hardware design. The SDA and SCL pin on both Uno and 24C02 are having open drain circuit. This means they can only actively pull the line down to the ground low. They cannot push the line up to 5 volt, that is high logic. How to fix? An external 4.7K resistor constantly pulls the line up to 5 volt. When the chip wants to talk, they will pull the line down. Without them, the line float in an undefined state, and the Arduino reads them as 0. This will lead to error in reading and writing. Steps to wire 240C02 EEPROM to Uno. Step 1. Connect A4 pin of Uno to pin 5 of 24C02 EEPROM. Step 2. Connect pin 5 of Uno to pin 6 of 24C02 EEPROM. Step 3. Connect plus 5 volt power line of Uno to pin 8 of 24C02 EEPROM. Step 4. Connect any ground pin of Uno to pin 4 of 24C02 EEPROM. Step 5. Pin 1, 2, 3 and 7 of EEPROM is connected to the ground. Step 6. Connect a 4.7K resistor one end to pin 5 of EEPROM and another end of the resistor to plus 5 volt. Step 7. Connect 4.7K resistor one end to pin 6 of EEPROM and another end of the resistor to plus 5 volt. The complete wiring diagram of 24C02 with Arduino Uno for writing and reading purposes is given in this page. This is the photograph of the testing bed developed in breadboard using Arduino Uno and 24C02 EEPROM. Circuit diagram for 4-digit display using LUT in 24C02 reading. Components needed: 7-segment display, common cathode, 4-digit block, 1 number, Arduino Uno, 1 number, data written EEPROM 24C02, 1 number, 74HC595 shift register IC, 1 number, jumper wires, 290 ohm resistor, 8 numbers, breadboard small, 2 numbers. The complete wiring diagram of 24C02 EEPROM with Uno and 4-digit display with 74595 and Uno is given in this page. This is the pin diagram of 74595 shift register. This receives the serial data in pin number 14 and converts them into parallel data on the click of on the latch high. This is the pin diagram of the 4-digit display combo module. Pin, the dot points are pointing downwards and left hand side is the starting point of the count, and pins are counted in anti-clockwise. Pin number 1 is segment E, pin number 2 segment D, pin number 3 decimal point, pin number 4 segment C, pin number 5 segment G, pin number 6 first digit common cathode, pin number 7 segment B, pin number 8 digit 2 common cathode, pin number 9 digit 3 common cathode, pin number 10 segment F, pin number 11 segment A, pin number 12 digit 4 common cathode. Here the user should note that all the digit A segments, all the digit B, C, D, E segments are interconnected together and given as one outlet. This is the wiring table of the 4-digit combo display, 7-segment display with the Arduino Uno. The left hand side pins are of that of Uno and right hand side pin numbers are that of the display combo display. This is the wiring pin connection for 24C02 EEPROM and Uno. The left hand side pin numbers are that of the 24C02 EEPROM, and right hand side pin numbers are that of the Arduino Uno. This table shows the segment connection between the 74HC595 shift register IC to the 4-digit combo display. The Q0 is the LSB and Q7 is the most significant bit MSB. The wiring of Uno with 24C02 external EEPROM. First step, connect your 24C02 IC to Arduino Uno using the following steps. Step 1. Connect VCC pin 8 of EEPROM to Arduino 5V power supply. Step 2. Connect pin 4 ground of EEPROM to Arduino ground. Step 3. Connect SDA pin 5 of EEPROM to Arduino A4 pin. Step 4. Connect SCL pin 6 of EEPROM to Arduino pin A5. Step 6. Connect A0, A1, A2 pin, that is pin number 1, 2, 3 of EEPROM to Arduino ground. This sets the I2C address to hex 50. Step 7. Connect write protect pin number 7 to Arduino ground. This disables write protection. And from this section, we are going to deal with the reading of data from 24C02 EEPROM. This section deals with the C++ code for sequential display using 74595 and 4-digit display with auto deduction of the common driving like anode and cathode. This is termed as the method 7. Warning: Uno cannot deliver power needed for 4-digit 7-segment display. One segment can take approximately 8 milliamps for reasonable brightness. 4 into 7 is equal to 28 segments are there, plus 4 dot points are there. 8 milliamp into 32 equal to 256 milliampere current is needed for average brightness of the display. Uno has to drive 74HC595 and 24C02 ICs. This has an impact on the onboard power supply. Uno has strict current limit to prevent the permanent damage to the IC on board. The per IO pin maximum current can be drawn is 20 milliampere and absolute maximum is 40 milliampere per pin. The total combination of all GPIO pins, the maximum current that can be sourced or sunk across all the GPIO pins combined is 200 milliampere. It is advisable to use transistor to drive display. The test circuit. A 390 ohms quarter watt resistor is used in the D1, D2, D3, D4 common points. This will limit the current to an admissible limit. This will have impact on the brightness of the display. It is advisable to use transistor-based display driver for good display luminescence. This is the first page of the code. Here the libraries and the pins and variables and constants and subfunctions are initialized. This is the second page of the code. Here the once executable setup functions are defined. Initializing wire begin and serial peripheral interface begin is initiated in this section. This is the loop section which will be repeating again and again. Here the loop advances from 0 to 9999 and the counter will repeat again. There is a gap of 2 milliseconds between each and every count. This is the fourth page of the code. Here the display type deduction method is given, and after deducting the type of the display, it will flash in the serial monitor the message. This is page number 5. Here the display value section is code is given. The number in the variable value is displayed in the 4-digit combo, a 7-segment display, and the codes can be one can understand the detailed working of the code in the working section. In this section, 2 sub-functions are defined. One, send data to the shift register. Second, reading from the EEPROM, the lookup table and the data. The working of the C++ code by method 7 is explained in this section. Overview of the working of the code is given in this page. The code operates a 4-digit 7-segment display by multiplexing the digit using direct Arduino pins, retrieving the 7-segment font data from 24C02 EEPROM and shifting the data via 24 HEC-595 shift register. Here is the step-by-step breakdown of how the code works. Hardware detection. The Arduino temporarily configures the first digit pin number 2 as an input with internal pull-up resistor. If the display is common cathode, internal pull-up resistor reads as a high. If the common anode it pulls the pin to low. That is, the pin number 2 will read low. It then configures the digit pin as output and sets them to an off state. High for common cathode, low for common anode to prevent ghosting. Section 2. EEPROM lookup table. The code accesses 24C02 EEPROM with the address 50H over the I2C bus via the wire library. It calculates the target address mapping to lookup table in a following way: display type and decimal point toggle, and select the correct font in the memory block. The character pins point to the specific digit pattern. It requests the return of 8-bit segment data, example 3F hex for a number 0. Section 3. This working of shift register communication. This function uses serial peripheral interface library to send segment data to the 74HC595. Pulling the latch pin low enables the data input. SPI transfer shifts out the 8-pin serially, returning the latch high, updates the shift register's storage output, the segments. Section 4 of the working, multiplexing and display. A value of 0 to 9999 is mathematically split into 4 individual digit arrays. The leading 0 blanking is applied. Example, if 0005 is to be displayed, it will be displayed as 5. The loop activates 1 digit at a time, sends segment data to the shift register for the current digit, turns the current digit on using the digital write for 2 milliseconds, POV of delay, turns the digit off before proceeding to next one to prevent bleeding and ghosting. Section 5, the main loop. Arduino counts from 0 to 9999. To prevent flickering, it continuously calls the display value for about 200 milliseconds per number before iterating to the next integer. The Arduino IDE with C++ code after flashing is shown here as a screenshot. The photograph of the working model developed with 1 digit, 2 digit, 3 digit and 4 digit display is presented in this page. The complete unit with EEPROM 24C02 and 74HC595 and the 4 digit display is captured in this image. The C++ code to read data from I2C EEPROM, display the data in 4 digit 7 segment display in a random way with 1 decimal point is dealt with in this section, and this is identified as method 8. This is the first page of the code. This is the second page of the code with setup. This is the third page of the code with loop section in it. This is the fourth page of the code with continuation of the loop section. This section describes the displaying the floating number with the decimal point. This section has the code to detect the display type automatically. This is the 7th page of the coding. This has 2 subroutines: send to shift register and read the EEPROM. One can copy all the 7-page code and put it into the IDE and compile and run the code. Working of the C++ code to read the data from I2C EEPROM. Display the data in 4-digit 7-segment display in a random way with decimal point. Method 8. A detailed walkthrough. Overview. The provided code is written for Arduino framework, compatible with Arduino Uno to interface with 2 external hardware components, a shift register via SPI and I2C EEPROM via wire library. Here is the breakdown of how each function works. Function 1, read EEPROM. This function calculates the specific memory address based on the 3 input parameter and reads 1 byte of data from I2C EEPROM. Address calculation. Set number function calculates the digit and the value, determines the specific character set based on the type of display. Target address set multiplied by 16 plus character calculates the exact byte address in the memory. Each set is allocated 16 byte. The I2C communication setup. The wire begin transmission opens an I2C connection to the device at a given slave address. The wire write sends the target internal memory location to the EEPROM. Function 2, data retrieval. Wire end transmission equal to 0 closes the transmission it returns to 0. The EEPROM acknowledges it successfully. Wire request from, and if wire available, checks if the byte arrived and reads it and stores in data. Return or data. Returns the retrieved byte to the main program commonly used for lookup 7-segment display font mapping. Function 4. Send to this shift register. Send to the shift register. This function sends 8-bit byte data to the shift register like 74HC595. The digital write latch pin low lowers the latch pin of the shift register. This prepares the register to receive the new data. SPI transfer transmits the 8-bit data byte using the hardware SPI bus. On an Uno, this pushes the data out to the pin 11 MOSI and clocked by pin 13 SCLK. The digital write latch pin high raises the latch pin high. This instantly moves the received data to the shift register output pins. Arduino Uno ID with method 8 code in it and with the uploading process. The image shows the random numbers with 1 decimal point displayed in it. Note on this test circuit, 390E 1/4 watt resistor is used in the digital pins of the display from Uno. This will impact the brightness of the display depending upon the number of segments lit in the display. It is advisable to use transistor to drive the display. Wiring a 4-digit display with transistor. Note on the transistor driver setup. Common cathode display uses 4 NPN transistor like BC547 or 2N3904. Connect the display digit pins to the transistor emitter and ground the collector. The common anode display for 4 PNP transistors like BC557 or 2N3906. Connect the display digit pins to the transistor emitter and hook up the collector to the plus 5 volt. Circuit diagram with NPN transistor driving the display. A code modification is needed in the display float subfunction in the last 2 lines. Please note the changes. This is the circuit diagram with the PNP transistor driving the display. This is the code modification needed in the display float subfunction in the code, and please note the changes. The hardware wiring diagram is repeated for after the inclusion of the transistor. Please, there is no changes to this section of wiring. This is the hardware diagram with the transistor. Please note the change, make the modification accordingly. A good habit in compiling. In case of encountering a strange, inexplicable compilation error, go to Sketch, verify compile, or press Ctrl R or Command plus R. If it persists, simply close the IDE completely, reopen it. This forces the fresh build environment and usually clears up any ghost errors. Conclusion. The 24C02 EEPROM can be used to store the lookup table. This is a fast and efficient way in microcontrollers where resources are less. Multiple digits can be managed with limited GPIO pins. The display is updated in every 2 milliseconds. The cost breakup of the kit is given in this page. Total is approximately 540 rupees without packing, without GST. One can contact the author for tips, support, assistance and guidance. Please contact for code and support. Kits are available for learning. Projects for schools and colleges can be designed. Contact the YouTube owner. Subscribe to my YouTube channel. Please subscribe to my YouTube channel by following the link. Thanks for watching. See you in the next episode.